Hi, my name is Brandon Graisley. I teach high school math, and I have a problem here that a number of my students are having difficulty with, so I'm going to explain how to solve it. This is a picture of a survey of a property, and this is a very simplified one. And you can see the corners of the property here at A, B, C, and D, and this would be the roadway over here at BC. In the middle of this property is a square house, EFGH, and from the corner of the house F, we know the distance directly to the road, 80 feet, and you can see this line here, this dotted line, meets the road at a 90-degree angle, and so there it's the shortest distance. And similarly to this other side of the property, it is a 40-foot distance, again meeting at a 90-degree angle to that point F. And so in the problem, we want to connect a power line to this house. We need some electricity, and the power line is going to connect to the point F, and it has to come from one of the existing hydro poles which runs down the length of the roadway, and it can either be along here to the point B, or it can be up here from F to C. And so the question is, which is the shorter of the two distances? And the reason that it really matters is because wiring is very expensive, and so in this problem I've got a cost of $16.53 per foot, which is probably pretty conservative. It's likely a lot more money than that to run wire, especially expensive thick wire like this wire would be. So which is the shorter distance, from C to F or from B to F? And we have to do some work to find that out. So we know a little bit of information, but we don't know tons and tons about all of the different pieces here. In particular, these angles, 68.71 degrees at this entire angle B, or we might call it ABC, and this one up here, 98.96 for BCD. Those are not the angles that we would need to sort of solve for this triangle right inside here, this purple one that I've started to draw. And so to approach this problem, we're instead going to look for other triangles first to help us find some lengths so that we can later solve for these sides. Now what we're going to do, what I would really love, is to know the length of this side from I to C here, because here I have a right angle triangle, and I need to know this length, which is the hypotenuse from C to F. I know one side, FI or IF, but I don't know this other side. If I knew it, even if I don't know any angles, I could use Pythagorean theorem to solve for that side. Similarly down here, if I knew this length here or this length here, that would be enough using my right angle triangles once again to use Pythagorean theorem. And it turns out that we can find those fairly easily. So what I'm going to do right here, I'm going to draw a horizontal line from F across to the roadway, meeting at a point which we're going to define. We're going to call K, because that's an unused letter. J is used down here. And that line is parallel to this line right here. So it's parallel to this roadway here, sorry, this edge of the property, and it intersects with the roadway. And then I'm going to draw another one right here from K down here, and this point we're going to call L. I don't know if we're going to need that letter, but there it is. So I've drawn a rectangle here. Each of these corners is 90 degrees, because this meets at 90 degrees right here, and I've drawn everything parallel and perpendicular. So all 90s there. And what I've ended up with now are a bunch of right angle triangles. I've got one right here, FIK is a right angle triangle, and I've got another little one over here, KBL is a right angle triangle. And so what I want to do is find these two lengths, BK and KI. So let's see how we can do that. First thing is we know angle B, and we actually know this side, KL here, this is 40 feet, because it is the same as this side over here. This is a rectangle. And so now we have an angle, and we have a side, and we can use that to find this remaining side. This side, KL, 40 feet, is opposite the angle B, 68.71 degrees. And we want to find this unknown side, the hypotenuse, which I'm going to call X for now. And so I can use the sine ratio. Sine is opposite over hypotenuse. So let's write this down. Sine of B, which is 68.71 degrees, is equal to the opposite length, 40 feet, divided by the hypotenuse length, which is X. So a quick solution here, I'm going to just rearrange and reorganize this. I'll move that up. I'm going to grab my fantastic old school calculator, and 40 feet divided by 68.71, pressing sign, and then equals gives me that length is about 42.9, we'll say 42.93 feet. Okay, that's pretty nice. So that one's done. What else can I use here? Ah, look at this. So x is 42.93. Sorry, let's finish that. See this triangle right up here? I know that this length on the short side is 80 feet. I don't know this length here. The whole side here is 211 feet. I don't know how much of it I've used. But I do know one other thing. I don't know this side here, but I do know this angle. This angle is the same as this angle because these two lines are parallel. So this angle here is, again, 68.71 degrees. Hey, I can use that to solve for this side. Let's call this side y. That's the length from I to k. And I know now, instead of sine, here I'm going to say, well, this is the opposite side and this is the adjacent side. That means I'm using tangent. So tan of 68.71 degrees is the opposite side, 80, divided by the adjacent side, which is y, which we don't know. So y is 80 feet divided by the tangent of 68.71. Let's calculate that. 80 divided by 68.71 tan equals, y is 31.17 feet, about. I'm going to write that up here in my diagram. Okay, and I'm going to add one more little bit here. Z is the length from I to C. Right up here, that's the last little bit. Well, Z, we know, is going to be equal to, can't really show this all at once, 128 feet minus x and y, because it's the only remaining part of the length. 128 feet is the length of this entire side of the property. So I'm going to subtract away these two sides to give me what Z is. So Z is 128 minus 31.17 feet minus 42.93 feet. And that's probably calculator worthy today. 128 minus 31.17 minus 42.93 is, I got 53.90 feet. That's the length Z. Okay, let's look at what we have in our diagram now. We know the length of each little bit over here, all of these sides. We now have enough to find the length from F to C. We know 80 feet over here on this long side or short side of the triangle. We know this short side of the triangle is 53.90. So the length of CF is going to be this squared plus this squared, and then take the square root. Let me just write that up here. The length of CF squared is 80 feet squared plus this side 53.90 feet squared. That is the Pythagorean theorem. This is a right angle triangle, and I'm trying to find the hypotenuse. So CF squared is, and let's work it all out here, 80 squared plus 53.9 squared. Press equals, and then press the square root button. Oh, sorry, I should wait until I've written this down. 9305.21. Taking the square root of both sides then leaves me with 96.46 feet approximately. So that's the length of this side, 96.46. Well, that's one side, one of my purple lines here. The other purple line I can find in a similar way. I have 80 feet here, and here x plus y, if I add those two things together, will give me the remaining side. Let me just write this right here. The side that I want, BF squared, that's the long side again, is 80 feet squared plus the sum of these two sides squared. Just make sure I get this right. Okay, 74.1 feet squared. So again, BF squared then is, we'll type this all in right here for you, 80 squared plus 74.1 squared equals 11,890.81, and then taking the square root of both sides, 109.04 feet. Okay, 109.04 feet. Alright, now I know that C is the shorter distance, so that's great. How much does it cost for the wire? The wire, I say in the problem, is, let me look, $16.53 per foot. So CF times 16.53 per foot is equal to, let me just multiply it all out here, 96.46 times 16.53. The cost for the to go from C to F is $15.94.48 to the nearest penny. And if I was being really accurate, I might have to round that up another cent. And the other side, if I take BF times the same price per foot, BF was 109.04. Multiply that by 16.53, and I get $1,802.43. So in this case, I would then write out that the length from CF is 96.46. Length of BF is 109.04, and then I would list the. I have these costs for each of them, and so I would say that to put the power line from F out to the upper one here, C, is cheaper, and I might calculate the difference. It looks like just over $200, about $206 difference between these two plans. So taking a step back now, looking at this problem, this might seem a little complicated. I've got a lot of stuff on here, but in the end all I've done is realize that I don't have the right triangles yet that I needed on my original diagram, so I added them in by drawing a horizontal parallel line here and then another perpendicular line. This gives me some triangles to work with, to use the Pythagorean theorem and to use the facts that I know about the trig ratios. Using those two things, I'm able to solve for some missing sides and then eventually use the Pythagorean theorem to finish everything off. So, long problem, kind of. The math that we needed to use wasn't actually that difficult. You just had to see where you could apply what you knew. I hope that helps, and thanks a lot.